Okay, let's continue here. Here's a video on tips and shortcuts. In this video, we will discuss recurring number for 1 over 7. Okay, we will discuss two ways to compute recurring numbers. One is by division, and there are two divisions, direct and indirect. We discuss them both, and also uh, compute that 1 over 7 using construction methods. Okay, it discusses spend significant amount of time to construct a recurring number for 1 over 7. Okay. This is video number 16, part 5 of 5. I split the video in 5 parts, and this is the 5th part. Okay, let us continue. Okay, let's go continue with next section here. Next section is converting between recurring numbers for 1 over 7. Okay, let's continue here. Reckoning numbers for 1 over 7. Okay. Let's try dividing 1 divided by 7. Okay. If you do that, is that hard? It's not really that hard. You just divide by a single digit, okay, and we just keep adding zeros to the after decimal place. It's straightforward. Okay. And what's the quotient? Did you get that number? 0.142857 and continuing the same numbers. Okay. Did you notice anything special about this division here? What's the quotient digit after last 7? How about more digits? If you continue there, you continue to get 142,857, 142,857, and so on. You see the quotient digits keep repeating. The 6 digits in quotient keep repeating. Okay? And they should do repeat. Such repeating numbers are called recurring numbers. So recurring numbers are numbers they are repeating. Okay, let's continue here. How do you find recurring numbers? There are two ways. Okay, the first, at least there are two ways I know of. Okay, let's continue is first division, direct and indirect. We just did direct division here. We had done indirect division in the division methods, which was Nicolet method. We did a 1 over 13 using its equivalent 3 divided by 39, and we did the same thing again in a transpose and apply method where we use 7 over 91 as equivalent of 1 over 13. Okay, so that's indirect method. This is direct we just did here. Okay, another is by construction. So we're going to use a construction method here to compute the same number, recurring number as we have here. Okay, let's continue. Let's go and construct that. And observation: number of recurring digits is 6, which is an even number. 6 is an even number, and number of recurring digits are 6, which is 142,857. Okay, let's continue here. A recurring number fraction has an equivalent common fraction form, okay, of the type, okay, which is 6-digit recurring number have a common fraction of this type. 6 digits in the numerator and 6 nines in the denominator. 6 digits in numerator and 6 nines in the denominator. Okay, now how do you get a nines, 6 nines by multiplying? Okay, we are going to use convert 1 over 7 to this form using multiplications. Okay, how do you get 9, 6 9 by multiplying? Okay, any ideas? Let me give you the ideas I know. First of all, you can get 6 is an even number, and you can get that two ways. One is 1001 times 999. 999 is 3 digits, and this is a 4 digits with the 2 zeros in here and 2 ones in the end. And also you can start with 6 ones and multiply by 9. Okay. Okay, so you can get 6 nines using these, and any you can use the prime factors of these things and say uh, make your life a little harder. So hey, make it harder, but these are simplest way you can get. This, okay, let's say this is last multiplication you need to do to get a 6 nines. Either you multiply these numbers together or this number together. Okay, let's continue here. If 1 over 7 has the above form like this, 7 must be a factor of both 1001 and 111111. Please you go ahead and verify. Okay, it is okay a factor. So and in fact 1001 is 143 times 7, and also 111111 is 111 times 143 times 7. How to get 143? One way is that I need a 1001 here. So I divide 1001 by 7. Another way to do is there's a subsutra which associates 143 and 7 through multiplication. So here's multiplication here, here's 143 and 7, and they both come out to 1001, and I would need that to compute a sequence of 6 digits, 6 nines. Okay, let's continue here. So you know that we are trying to convert equivalent form of 1 over 7 in this form here. 6 digits in the numerator and 6 nines in the denominator, and that would give me a recurring number of 6 digits long. Okay, let's continue with construction of 1 over 7. Now we can construct a recurring number for 1 over 7. We have already developed all the products we need to multiply and divide by. Let's continue here. We start with 1 over 7, okay, which is equal to 1 over 7. Okay, no problem there. Straightforward. Okay, is exactly equal to. Then we are going to multiply and divide by 143. That was our first multiplier. Okay. We did multiply and divide by 143. Okay, let's see. Then after that we want to multiply, get all nines in the denominator. So we multiply and divide by 999. Okay, let's continue here. Let's continue. Okay, then from here denominator is 7 times 143 times 999 is all 6 nines, 999, 999. That's what we know from the workout in the previous slide. And numerator is 1 times 143 times 999, and which 143 times 999 is 142857. We are multiplying by sequence of 9, and we have done that before, and it okay, that is equal to 142857 divided by 999. 999,999. Okay. Okay, and for this multiplication, you can refer to multiplication by sequence of nines in this video here. Okay. Let's continue here. So 1 over 7 is again is equal to 0.142857 recurring. If a denominator was 1 million instead of 999,999, it would be exact fraction 0.142857, because division by a base number is just moving decimal place to the left. Okay? But this is a 1 less than the base number, so in that case this becomes a recurring fraction. 1 over 7 is 0.142857 recurring. Okay, let's continue. Now let's look at some properties of the 1 over 7. Okay, which is the first thing we're going to take a look at cyclic property. Observation: you can take 6 digits starting at any position of 142857, and you get a recurring number of the for n over 7, where n is in 1 divided by 6. Let's continue here. Let's first try to construct a recurring number for 2 divided by 7. Okay? So numerator is 2 times 143 times 999, which is 286 times 9999, and which you know using the video previously discussed methods of multiplying by sequence of 9. You get 285714. On the left it's 1 less than this number, on the right it is all from 9 and last from 10 of 286. Okay, so 714. Let's continue here. Do you see that to be 6 consecutive number? Say these are 285714. Okay, these are the same number digits we have. We had 1 4 2 8 5 7. Okay, before in 1 over 7. For 2 over 7 we got 285714. We start at 2, we got 285714. We got 2 divided by 7. Okay, let's continue here. So this is what we got. If we say put together two sequences here, 142857 followed by 142857, we start at 2, take 6 digits, 2857 14 285 714 285 714. We got 2 divided by 7. Okay, let's continue here. If we start at 4, which is next second digit here, we got is 0 0.42 0 0.42857 and 1 is that's the recurring number for 3 over 7. Okay. You start next digit here, which is 2 285714 is a recurring number for 2 divided by 7. Okay. Okay, now we do a next digit here, 8, start at 8 here, 857142 is a recurring number for 6 over 7. Start at 5, 0 0.571428 is recurring number for 4 over 7. Okay, start at the 7, right here 7. We got 0 0.714285, which is recurring number for 5 over 7. So we got 1 over 7 was this number here, 2 over 7 is that number here, 3 over 7 is this number here, 4 over 7 is that number, 5 over 7 is that number, and 6 over 7 is that number. Okay, let's continue. Okay, let's see where you can use the cyclic numbers. Okay, these so what? Okay, in some situation these can make you look like a genius. Okay, let's continue. Determine 23 by 7 to 6 places after decimal. For that, you know, that is a snap. For you, that's a snap. And it's a 3. First of all, it's 7. It's a 3 in a whole number, and 2 divided by 7 is a fraction, which is, so you start at 2, 285714 recurring. Okay, so that, okay. What's 155 divided by 7? 155 has a 22 whole numbers and 1 over 7 as a fraction, so which is 22.142857. And how about 39 by 7? That's a 5 as a whole number, 4 as a fraction, so that's it is 5.571428 recurrent. References, you know that there's a reference of first reference is this Vedic Maths ebook.com, memory mentor underscore maths underscore tips.pdf. I got most of the ideas from this book ebook, and but I use my own approach. Okay, my approaches are different. This ebook has numerous other tips and shortcuts. Okay, so it has a multiply by 11, multiply by 12, square of numbers ending in 5, and some other working with the times also. Okay, let's continue here. Next is a teacher's manual, Vedic Math teacher's manual, elementary level by Ken Williams, and this book is available from vedicmaths.org site. And if you look at PDF form, that is free. Then look up primary reference for anything Vedic math is Bharati Krishna Tirthaji's book, Vedic Mathematics. An authoritative book is Discover Vedic Math by Kenny Williams. It's the most complete book, authoritative and consistent notation. The book organizes the material by sutras. Okay. And then Glover's book, 3 books. They are very easy to read and are not as complete as either of the first 2 books are, but it's easier to read and cover most of the topics. Okay, and yeah, it has plenty of geometry which I have avoided. Okay, let's continue.